compositional functions. You might also hear them called composite functions. And this is all about substituting one function into another. We're also going to look at the inverses of functions. So composite functions and inverse functions. Okay. So compositional functions or composite functions. So you will see both of these forms. You'll see this form as well as this form. And they're both read f of g of x. And it's basically, what it tells us to do is it says take the function g of x. So say we're given g of x here, and we're going to substitute it into the x of f of x. So if you can see below, f of g of x, which could also be written like this, equals, so we've got the 2 from f of x, that coefficient. Instead of x, we've got all of g of x. So g of x is substituted in for the x. The squared from f of x stays the same, and we've got our plus 3. So everything stays the same, we're just substituting g of x in for the x of f of x. Here's another example of that. We can also do g of f of x. So, and again, they're both read that way, g of f of x. It's telling us substitute f of x in for the x of g. So now we're going to take f of x, and we're going to substitute it into this x of g. And it's very important to keep it in brackets. So we'll have the function g, we'll have our coefficient 4. We've got, instead of x cubed, we've got f of x cubed, and then plus 1, which comes from here. Okay, and then of course you could expand that, you can simplify it, but this is just the beginning. Okay, we could also do f of x. So what that means is we're going to take f of x, and we're going to substitute it into the x of f of x. So looking here, we're going to take f of x, okay, and if you can imagine, we've got the same function f of x. We're going to substitute that in for this x, okay. So we'll keep this coefficient of 2 the same. Instead of an x squared, we'll have f of x squared and plus 3. Okay, so whatever is in the middle brackets goes inside the function in the outer brackets. Okay, so we're going to practice this with multiple functions. We'll simplify it, and then we'll also find g of f of 2. Okay, so we'll first find f of g, then g of f, then g of f of 2. Okay, so f of g for the first function here. F of g of x. So it's saying we're going to take g of x, taking g of x, and we're going to substitute it in for the x of f of x. So we'll have 1 over x minus 1 minus 5. So instead of x minus 5, we've got g of x minus 5. And we can simplify that by combining it into one fraction, getting a common denominator. So 1 over x minus 1 minus 5 times x minus 1 over x minus 1. We'll be careful to distribute the negative, this negative to both terms. So we'll have 1 minus 5x and plus 5 over x minus 1. We get 6 minus 5x. Okay, so this is f of g of x. If we wanted to find g of f of x for those same functions, instead, we'll take f of x, this function, and we'll substitute it in for the x of g of x. So we'll have 1 over instead of x, we'll have x minus 5, because that's what f of x is, and then minus 1. So we get 1 over x minus 6, and that's it. That's our function. So that's g of f of x. If we want g of f of q, that's what it's asking us here. Find g of f of 2. We're just going to take our g of f of x function that we just found here, and we're going to substitute 2 into it. So 1 over 2 minus 6 gives us 1 over negative 4, or a negative 1/4. Okay, so that's all A. If we look at B, it's the exact same thing. So let's look at C. We don't need to do that twice. C. We want to find f of g of x. Okay, so it's saying take g of x, put it inside f of x, in for the x of f of x. So f of x tells us to be the square root. And then instead of x, we're going to have g of x, which is x squared. The square root of x squared. Don't forget, when you take a square root, you always need plus or minus. And the square root of x squared, of course, is x. This is f of g of x. And if we want g of f of x, we're going to do the opposite. We're going to take f of x and substitute that into g of x. So we're taking f of x, substituting it into the x of g of x, and we'll have square root of x squared, which is just positive x. When we square something, it always becomes positive. And then if we want g of f of 2, we're simply going to substitute 2 into the function that we just got. We just got g of f of x is x, which means g of f of 2 is going to be 2, and that is our x. Okay, letter D then. We want f of g of x. So it's saying take g of x, substitute it into the x of f of x. So we'll have 2 times the square root of x minus 2 as our function. And g of f of x. So it's saying take f of x, substitute it in for the x of g of x. We'll have the square root of 2x minus 2. If we want g of f of 2, we'll have 2 times 2 minus 2, or the square root of 4 minus 2, which is square root of 2. Okay, so some things to notice. F of g of x and g of f of x will not always necessarily be the same. In a very rare occasion will they actually be the same. And that occasion happens to be when they're inverse functions. We're not actually going to look at that in class, but just for your own information. So inverse functions, they're denoted with this notation. F, it looks like to the negative 1, but it means the inverse of f. So what it does not mean, this is very important, is that we do 1 over f of x. For example, like 2 to the negative 1 means 1 over 2, but this is a particular function notation. So it's not talking about, it's not an exponent, it's not a negative exponent of f of x. It doesn't mean that. So it just means the inverse of a function. And the inverse reverses the original function by reflecting it over the y equals x line. So what happens when we do that is that if we take f of a and that equals b in the original function, the inverse of b is going to equal a. So let's look at these points. So we're talking about in the original function, we're talking about the point a comma b. Okay, this is in the original function. So then in the inverse, which we represent like this, the inverse function, we've got b comma a. We've got x as our b and a as our y. So all that happens when we do the inverse of a function is our x and y's switch. So notice our x of a becomes a y, and our y of b becomes an x. And that happens because the function is actually reflected over the y equals x line. So this line, right down the middle, y equals x, a linear function with a slope of 1 going through the origin, is our point of reflection. So when we have inverse functions, it's going to take the original function, which is shown in red here, and it's going to reflect it over the y equals x line. And what that does is it switches all the x and y points. So notice in the original function, we have the point 0, 1. Okay, it's that point, we've gone 0 over, 1 up. And notice in the inverse function, we have the point 1, 0. We've gone 1 over and 0 up. What other points can we find? Here we have the point 2, 4. And in the inverse, we have the point 4, 2. So that's what's happening with every single one of these points. When you do the inverse of a function, it's just going to switch the x values and the y values. Okay. And here's another example of that. So if we have the y equals x line, something like that. Okay, so if we have that y equals x line, again, if, say, in the original function, we have the point 4, 7, this point here. In the inverse, if we do the inverse of that point, or if we were to do the inverse of that function, we would just simply switch the x and the y values. So we get the point 7, 4. Same with if the original function has the point -5, 3. To get the inverse of that point, we would switch the x and the y values, and that gives us the point 3, -5. So notice the negatives don't switch at all. The entire x and y value switches. So the y becomes our x, and the x, which is -5, becomes our y, which is still -5. Okay, so we can also find functions algebraically. So we just looked at geometrically how we can find inverse functions. We can reflect them over the y equals x line. But algebraically, we can also find functions. And we do that following these steps. So we're going to replace f of x, or g of x, or p of x, or whatever our function is, with the variable y. We're going to trade places. X and y are going to trade places. So we're going to switch the x and we're going to switch the y. And I'll show you how to do that. We'll then solve for y. We'll get y alone. And then we'll write the function in inverse form. So we'll say the inverse function of x is equal to whatever you just solved for. So what that looks like is, so originally we have h of x. We're going to replace h of x with y. So we're going to say y equals x plus 5 over 4. So you're replacing f of x, or h of x in this case, with y. Okay, so that's our first step. Our second step is we're going to switch, x and y are going to switch places. So instead of y equals, we'll have x equals, and y plus 5 over 4. So x and y switch places. then we'll solve for y. So we want to get y alone. So we'll need to multiply 4 to the other side. We'll get 4x equals y plus 5. Then we'll minus 5. So we have 4x minus 5 is equal to y. And then our last step is to write it in inverse notation form. So our original function was h of x, which means we'll have the inverse of h is equal to 4x minus 5, whatever you get for y. Okay, we'll do the same thing with this function here. Now we've got f of x, so we're going to replace f of x with y. Y equals square root of x plus 5. So that's this step here. Our second step is we're going to switch x and y. So instead of y equals, we'll have x equals, and we'll have the square root of y plus 5. So we switched our x's and our y's. Then we want to solve for y. So we can square both sides. We get x squared is equal to y plus 5. And then we can minus 5. So x squared minus 5 is equal to y. So we've solved for y. And then we want to write the equation in inverse notation. So our original equation was f of x. So the inverse of f is equal to what we just got, x squared minus 5. And if you were to graph both of these functions, you would see that they are actually reflections of each other over the y equals x line. If you think about the square root function, this is going to be over 0 at negative 5, something like that. And the inverse is going to look like that. So you notice that they'll be reflected over the y equals x. Okay, a couple more examples. Here we've got p of x, so we'll replace that with y. We're going to multiply 4 over, we're going to switch x and y. We're going to get x equals 4y squared plus 5 over 4. We'll switch, then we'll multiply our 4 over 4x equals 4y squared plus 5. We'll minus 5. And then we'll divide by 4. So we have 4x minus 5 over 4. And then to get y, we'll just simply need to square root both sides. And don't forget the plus or minus. Anytime you take a square root, you need to plus or minus. And what does that give us? Okay, so we've got our original function was p of x, I think? Yes, p of x. So p of x, the inverse of p, is going to be equal to plus or minus the square root of 4x minus 5 over 4. Okay. And this last one. G of x is equal to the absolute value of x plus 7. So we're going to replace g of x with y. And we're going to switch x and y. So x equals the absolute value of y plus 7. Okay, then we have to think about, okay, what does absolute value mean? Remember we said if we have the absolute value of x is equal to, say, 2. That means x is equal to positive 2. And x is equal to negative 2. Okay, so the same thing is going to happen here. If we want to take away the absolute value sign, we have to say, well, y plus 7 is equal to positive or negative x. So whatever is outside of the absolute value sign, when we take away that absolute value, we have to have that plus or minus. So then we'll minus 7, so plus or minus x, minus 7 equals y, and we'll replace y with the inverse of g. And that's it. want to also talk about the answer to this question. Is it a function? Okay, so looking at this first one here, does the inverse we get, is that a function? Is 4x minus 5 a function? Well, absolutely. No matter what we put in for x, we're only going to get one value for y. And we can also see that it's linear. It's a line. If we graph it, we know we've got a y-intercept of -5. We've got a slope of 4. It is definitely a function. It will pass the vertical line test. Same here. Our inverse of f of x that we get here, x squared minus 5, well, we know that's a parabola. We know no matter what we put in for x, we're just going to get one value for y. And if you're not sure, you could try multiple values for x. You could try 0, you could try 1, you could try -1. And you would realize that never will you get more than one value for y for the value that you put in for x. Okay, and then this one here, the inverse of p. This one is not a function because of the plus or minus. So if we put in a value for x, say 2. If we put in, say, x equals 2, if we want to find the inverse of p of 2, we'll have plus or minus the square root of 4 times 2 minus 5 over 4. So that gives us plus or minus 8 minus 5 gives us 3 over 4. So we've got plus or minus the square root of 3 over 4. We can simplify that as the square root of 3 over 2. And the square root of 4 is 2. And still that plus or minus. So we've got two solutions here. We've got a positive square root of 3 over 2, and we've got a negative square root of 3 over 2. And that's for just one value of x. So that means this is not a function. Not a function. So the original function is a function. If you look at p of x, no matter what you put in for x, you'll get one value for y. And you could test that, and immediately you can see that if you put in one value for x in the inverse of p, you will get more than one value for y. So not a function. Same thing here with g inverse of x. Again, we're dealing with a plus or minus. So if we put in, for example, 0 for x, if we find g inverse of 0, oh, 0 is the only one that doesn't give us 2. Okay, if we try 1 of 1, plus or minus 1, minus 7. So we have to look at two options. We'll look at positive 1 minus 7, which gives us a -6. We'll also look at negative 1 minus 7, which gives us -8. And those are two different solutions for exactly one x value, which means this is not a function. Even though the original is a function. So just because the original is a function does not mean the inverse will necessarily be a function. And as you go on with your math careers, you'll find that we can actually make these inverses functions by limiting their domains. We won't look at that this year, but if you're interested in that extension, I'm happy to teach you that as well. Okay, last example we're going to look at. This is a little more extended, but still part of our curriculum. So if we're given f of x is equal to 3x plus 2, we want to be able to find f of x. So it's saying take f of x, which is 3x plus 2, and you're going to put it inside f of x for the x, which is 3x plus 2. So we'll have 3 times instead of x, 3x plus 2. It's important to keep that in brackets. And then this last plus 2. So all we've done is taken f of x and put it into the x of f of x. And when we simplify that, we'll have 9x plus 6 plus 2, or 9x plus 8. So f of x is 9x plus 8. Okay, 1 over f of x, we haven't looked at that yet. 1 over f of x means exactly what you think. Take 1 over your function. If this is f of x, we'll have 1 over 3x plus 2. Then it's telling us, take that and substitute it into the x of f of x. So we know f of x is 3x plus 2. We're going to take 1 over f of x, and we're going to substitute it in for this x in f of x. So we'll have 3 times 1 over 3x plus 2. And then this plus 2. And we can simplify that. We can get a common denominator. We'll have 3 over 1, which when we multiply straight across, we'll get 3 over 3x plus 2. And then the plus 2 will need a common denominator. So 3x plus 2, 3x plus 2. So that is f of 1 over f. Okay, last one, and this is different. So letter C. We're looking at f of 1 over x. Do you see the difference there? It's not f of 1 over f of x, it's just in the middle. We've got f of 1 over x, which is different. So we know f of x is still 3x plus 2. Okay. So we first want to find f of 1 over x. So it's saying take 1 over x and substitute it into the x of f of x. So instead of 3x plus 2, we'll have 3 times 1 over x plus 2. Okay, so this is f of 1 over x. Okay, and now we're going to take that, and it's saying substitute that into the x of f of x, which we know is 3x plus 2. So we're going to put that into this x. So we'll have 3 times 1 over x plus 2 plus 2. So all of this is here. And then we've got our coefficient of 3, and we've got this plus 2. Okay, so simplifying, we've got 3 times 3 over x plus 2 plus 2. We can multiply our 3, so we'll have 9 over x plus 6 plus 2, which gives us 9 over x plus 8. And that is equal to f of 1 over x. That's our final solution. Okay, thank you.